Hi, welcome to the science question and answer session. Today we will be seeing the question related to science on motion in straight line and the Newton's laws of motion and work, energy and power. These three areas are covered in this question. So let us just go and check what the question is about. We need to calculate the potential energy of the hawk when it is 150 meter above the earth. The mass of the hawk is given. Now if you see here, we can see that there are a few parts of the question. One part of the question is about this work energy is given. So first part, since we have work, power and energy, I'll just start with this potential energy, since there's a question about the potential energy. Mass is given in kilogram, gravitational field strength is Newton per kilogram, and also height is given in meters. So we need to be careful on units of this. Potential energy means it's an energy that is stored in an object in a particular position. So potential energy can be calculated by mgh. So we shall see what the question is asked about. Is the following diagram below shows the flight of a hawk. The hawk comes and catches the rabbit and then it flies back to air. This is what is given. A hawk is staying up on the sky, right? The flow is here, right? When we are calculating the potential energy, it is always the height means perpendicular height. That is the, so it's not the distance traveled exactly. It is called as displacement. As displacement is given as 150 meter, right? 150 meter, and the mass of this one is given as 1800. So we will see how we can do with this question. So we know that potential energy is always calculated with the equation mgh, mass, gravitational force, into height. So mass is given as 1800, so 1800 is given, and g always they normally give, since this is a paper that is not past paper, this is a Western province paper, so they have not given, normally they give, otherwise you can take g as 10 Newton per kilogram, and h is they have given as 150 meter, right? We have to change this, we have to be careful here. We can see that the g, the gravitational force here, is given in Newton per kg, all right? So always we have to be careful when the mass is given to convert that into kilogram. I have just converted the grams into kilograms, and then I have calculated the potential energy. The conversions are very important here, otherwise you will not get this answer gram. So you should be knowing what's the gravitational force will be. So otherwise it will be given in meter per second squared. That unit is there for that. What are the equations we have? Distance, speed means distance divided by time. So this distance is not the displacement, right? So that's what we have to be careful about. Now velocity comes, that is a displacement divided by time. And then we have the acceleration, change of velocity by time. What's this displacement and distance we were talking about? You know that you have learned there are two places, A to B. So these two places can be reached at different ways, right? Let's say this means 400 meters. And if you take the displacement, we always take the displacement for the velocity. Displacement is the shortest distance between these two positions. Shortest distance means here maybe, now let's say it's surely going to be less than 400. So velocity and speed will change. Speed is not calculated with the direction, so we call it a scalar quantity. But when we take the velocity, we call it as a vector quantity. That means it is calculated with the direction. We can say that velocity is always a vector quantity, but the speed is a scalar quantity where there is no direction is involved, right? And also we should be able to know what's the acceleration means. Acceleration is always calculated the change of velocity divided by time. Let's say a car is moving. Normally a car starts from the speed 0 and it goes accelerating. So when the car accelerates and goes and it gains speed, so we can say it started with 0 speed and it has reached some 20-30 meter per second. And so there is a velocity here, started velocity, right, and end there is a velocity, there is 20 meter per second. So change of velocity, so change here is going to be 20 minus 0, so that's the change here. So the change of velocity here is going to be 50 minus 20, that is going to be 30. Difference is 30, you can see. So here the acceleration is acceleration always calculate the change of velocity. Here you can see 50 minus 20 is 30. Here the acceleration is from 0 to 20, so different times, different ones. So acceleration is given means you can calculate using this equation. Now the question is asked, the hawk starts its flight instantly from rest. It flew 5 seconds with uniform acceleration of 4.8 meter per square and maintained its velocity for 3 seconds until it reached the prey in a linear path, right? So find the velocity the hawk within the first 5 seconds. So we will just concentrate on few words here, right? So it starts its flight instantly from rest. That means started from 0 speed, right? And also it flew 5 seconds with uniform acceleration. You see the words here, the uniform acceleration is given. Uniform means it's not changing. Acceleration will not change from start to end. Always it just you have given the correct acceleration, unchanged acceleration 4.8 some. Actually practically it is not possible. Since this is a question to make easy for you, they have given like this. So it has maintained its velocity for 3 seconds. Change of velocity equals acceleration into time. You have studied, we have seen the acceleration equation. If you take acceleration equation is equals to change of velocity divided by time. So if you just multiply this side, acceleration in time, acceleration to time, change of velocity is equal to acceleration into time. So acceleration is given as 4.8 meters per square. It flew 5 seconds with uniform acceleration. So uniform acceleration time is 5 seconds. So you have to be careful here. It's 5 seconds it is given. So 4 meter per squared. So seconds squared, there's no problem. We are safe here. We don't have to change any units here. So change of velocity is going to be 24 meter per square. That means from 0 until it reaches a maximum speed of 24 meter per second will be that. So final velocity minus initial velocity, that's the mean. Change of velocity means final velocity minus initial. Initial was 0 and final is this much. So average velocity within first 5 seconds we calculate like this. So you take the initial velocity plus the final velocity and divide that by 2, you will you will get the velocity within the first 5 seconds. That is going to be 12 meter per second. So that's why I have given 12 meter per second. And then next question is, what is the displacement of the hawk when it flew in acceleration? This formula can be used to find this answer. What is displacement of the hawk when it flew in acceleration? Acceleration is there. Can we find the displacement using this equation? No, we cannot. You have to think of a different equation. That is this equation, velocity equals displacement divided by time. So that's why we earlier found out the velocity, right? Displacement and time is there. So using this equation, we can find that answer. So displacement on first 5 seconds equals velocity into time. So velocity into time. So using this one, I have made this. So velocity is 12 meter per second into time is given. So it's going to be 60 meters. It got displaced within first 5 seconds. The next part of the question is asked, find the total displacement of the hawk during the 8 seconds. So we know that displacement is equal to velocity into time. Velocity is 24 meters in the after 5 seconds to next 3 seconds. It continued with the same speed that it gained, right? So 24 into 3. So it gained 24 meter per second within 5 seconds. So it continued with that. So 24 into 3. So that you will get 72 meters. So displacement in the next 3 seconds is 72. So the total displacement is going to be first 5 seconds 60 and second 3 seconds 72. Altogether it has got 132 meters displacement within 8 seconds. Now next question asked is this one. Draw the velocity time graph to show the flight of the hawk during the 8 seconds, right? So we calculated the change of velocity to be this much, 4.8 into 5 seconds, 24 meter per second. So velocity and time you have to take the velocity time graph, put the x-axis as time and y-axis as velocity, right? First 5 seconds it was accelerating, increasing, the gaining. The velocity was gaining, and then it has reached 24 meter per second, and then it got 24 meter per second and continued with that for 3 seconds. So this will be like this. So if you are asking me why this is here a straight line, because straight line, the parallel to time, when the time changed, the velocity did not change, right? Because it said in the question, it said very clearly, if you can see, it flew 5 seconds with uniform acceleration of 4.8 meter per second and maintained its velocity for 3 seconds until it reached prey. All right. So it maintained the velocity for 3 seconds, which it gained. That we found out to be 24 meter per second. That's the maximum speed it reached. So it will continue with that. So there is no change of velocity because it did not accelerate after. So that's the reason that we got a straight line parallel to the time, no change in the velocity, only the time changed. So 24 meter per second. So this is the graph. This is the velocity time graph they asked us to draw. So displacement, if you are calculating using this velocity time graph, also possible. You see, first 5 seconds displacement is given by the area of the triangle, and second one will be given with the area of the displacement. Is I'm talking about area of this the rectangle. Area of the triangle will give us the displacement on the first 5 seconds, and the area of this one, area of the rectangle, will give us the displacement on the second 3 seconds. So you know that how to calculate the area of a triangle is half into base into 5, and the vertical height is 24. That's how it got. So 2 and 24, 12. So that's why we got 60 meters on the first part. And second part, we calculated the displacement when the velocity was not changing, 24. The breadth into length, breadth is 3, length is 24, so 3 into 24, we found out that to be 72. So this total area will give us the total displacement within that time. That way also we can calculate the total displacement. So next part of the question asked is this one: the prey with a mass of 600 grams fell down to the earth. Draw the velocity time graph to show the movement of the prey falling down to the earth from the rest. So we are going to draw the velocity time graph. Here one thing we have to remember, that the prey with the mass of 600 fell down to earth. So you know that the potential energy is converted into kinetic energy here. So potential energy is calculated with mgh, right? Mass into gravitational force into the vertical height, and also the kinetic energy is calculated half into mv squared, mass into velocity squared. Here we can see with this equation, mass and mass will cancel off, so gravitational force into height will be equals to half into v squared. Now the prey is here, right? This is the prey. It falls down to earth. This is what happens, right? The prey falls down to earth. It might have traveled h meters, right? So there is a potential energy mgh here, so it just changed into kinetic energy and came down. The potential energy decreasing and the kinetic energy is increasing. We got final velocity. That means velocity would have increased when it reaches down, right? When it reaches down. But will the mass of or the object change the final velocity? If you ask, it will not affect the final velocity. So that's why we said MMM can be cancelled. There is no where velocity is involved with the mass here, right? Because here we take the frictional force as to be 0. So we don't consider all those things. We are not complicating this. So since the mass is whatever the mass, the final velocity will be equal, right? Now we have to draw this one. We can draw the time velocity graph. So what we are going to do is, we don't know the final velocity, so we don't give a value for that, and also we don't know the time taken, how much it's going to take to reach the ground. So if we knew height, we could have found the time. If we knew the velocity, we could have found the height. So but we don't know about this, only we know the potential energy. With that, we cannot calculate the time or velocity required. So we have just shown a general diagram like this. So next part of the question asked is, briefly explain the Newton's law relevant to the above incident. This is the first Newton's law we don't use here. Newton's second law says, and the acceleration of a body is directly proportional to the unbalanced force action on it, whilst it's inversely proportional to its mass. So from there we can take the equation F equals mf. The force is acting on its object gives rise to an acceleration. The hawk was carrying the rabbit and it fell down. So the reason they are asking is, explain this, why it fell down. So the reason to fall down is this one, F equals ma. That means there is a gravitational force on this object. So that gravitational force pulls down. Ma means mass into gravitational force. Gravitational force is there always on the earth. So that pulls that down. So that scenario gave, so the object came down here. So the Newton's second law is used here, and object came down, right? So I hope everyone understand that. So a brief description is given already. So next part of the question is asked, mention the reason for prey to stop after being drawn to certain distance when it fell from the sky. We can see our rabbit is down there and he's not moving. The hawk is there up looking down. What happened to the rabbit maybe? So rabbit is why the reason the prey to stop is a question. Newton's third law says for every action there is an equal and opposite reaction. So we know that there is a force. Reason is the force given by the flow to the opposite direction. So all the kinetic energy is lost as sound, heat, and small movement. So when it fell down, there was a sound, kinetic energy, the speed was there. That kinetic energy is lost as a bit of sound, a little bit of heat, and a small movement that it moved. So main reasons are the opposite direction. There is a force given to the rabbit or the prey. Hope everyone understood the answers. Thanks for joining with me for science question and answer part. So let's meet on the next question and answer session. Till then, have a nice time and goodbye.